1.4, we're going to solve some equations. So that's what we're going to focus on today. So when we solve equations, we're really going to focus on inverse operations. And that's pretty much it. So when you have a mathematical expression, 3x, that means 3 times x. We're multiplying x by 3. To solve an equation, we would do the inverse operation, which would be the inverse of multiplication, which would mean to divide. So if I were to say to you, I'm going to put operation, and then I'm going to put inverse. And this is very simple stuff, but I want you guys to just play along with me. If the operation was to add, what's the inverse mathematical operation?
Subtract.
Subtract, okay? If it was to multiply,
Divide.
are you guys writing this down?
Yeah.
What's that say? Is that solving what is it?
If I were to square something, what would be the inverse operation to square something?
Square root.
Okay? And so on and so forth. Does that make sense?
Yes.
All right. So now we're going to solve some equations. Example number 1, and this is really basic. Really basic. I could probably do these in 10 minutes with you guys, but we'll go through it. What's the solution of 4x, or x plus 4 minus equals minus 12? So now, what I'm saying to you guys, when we're going to do the inverse operation, we look at x. Okay, x is what we're solving for. So my goal is to get x on one side of the equal sign and all the other stuff on the other side. And we do this through mathematical inverse operations. So on the same side of x, I'm adding 4. So to move the 4, what's the inverse of addition? Subtract. So I'm going to subtract 4. Whatever I do on one side of the equal sign, in order for the equation to be balanced, I have to do on the other side. That makes sense? So then I get x is equal to negative 16. Any questions on that one? Now lastly, I suppose the one thing that I could do is double check. So sometimes we want to check to see if the solution, because I could have made a mistake mathematically. This is only a one-step equation. But maybe when Mr. Adams wrote down the problem, I forgot to write it down. Maybe I wrote down a negative 4, or forgot the negative sign for the 12, or something like that. So one way I could double check the problem is I could take my solution, which is negative 16, and plug it into my original equation. In other words, this is where my x used to be, but I plugged in my solution to see if it's true. Well, negative 16 plus 4, that is actually negative 12. So my solution worked. Does that make sense?